Welcome everyone. So this is a new series that I am starting. This will be about making a machine learning framework from scratch in C. I'm not trying to make anything like scikit-learn or anything. I'm just trying to understand how the most common algorithms in machine learning work, right? And how we can implement them on our own. So before that, before we move forward, the first goal is to understand how we can have some sort of NumPy like tensors. So I have some sort of a previous idea about how to build that. I'll I'll just directly start and see where we move forward. So I have this file if and tensor.h where we will define all the tensor operations. So my thinking is we can define some sort of tensor like, let's say, let me to define tensor h. Let's define a struct. See, sometimes this LSP behaves differently. Type def struct. What should we call it? Should we call it a vector or a tensor? A vector is a 2D thing, right? But what we're trying to do is it can have multiple dimensions as well. So that's what I'm trying to do. Let's do tensor. Why is it still coming here? Let's see what it should have. So I am thinking of storing data in double format. Let me know if float would be better. So the range is much better in double, although it is of 8 bits if I remember 32, sorry, 32 bits in 32 bits or 64 bits. So it is a 8 byte thing, right? So 64 bit. Float is of 4. So it is half of size of this, but the range is much better in data and the precision is much higher. So we will keep that as double. So each tensor that we define, it will also have the number of dimensions, and it will have uh, something called shape. And since shape cannot be negative, let's keep it as size t. What do you say? Size t, right? What else it can have? It has data, it has shape. We will also have something called strides. It will be made up of int vector. So strides will be an array which will give us the offset when we are trying to travel in some sort of a dimension. So suppose you have a tensor of shape 2 comma 3, right? 2 comma 3. And if you are traveling in the column dimension, you can only skip 1. So in memory, if it is a row major layout, and we are going to define it as a row major layout as well. If it is a row major layout, then for the last dimension, if you're traveling in the last dimension, it will skip it by 1. So how will it lay down is we will have row 1 elements which will go from 0, 1 and 0 and 1. Then we will have row 2 elements which will go from, sorry, it will be 0, 1, 2, and row 2 elements will be will be going from 0, 1, 2 again. Now, if we they will be laid in a contiguous manner in the memory. Now, if we're trying to access, let's say 1 comma 2, which is first row 1, let me rename it again and it will be much easier. It will be row 1 and the second column, which will be the last element, which will be 2. But if we are trying to access 1 comma 1, we will just have to move 1 in the direction backwards. So that is it. But suppose if we are going from 1 comma 3 to 0 comma 3, we need to skip 3 elements. So we were on this particular position. Then if we are going to 0 comma 3, we need to skip 3. So when we're traveling in the first dimension, we have to skip according to how many number of elements and sprites the other dimensions later on have. So let's create a function tensor. It will create a tensor. What will it take? So let's not have any data for now. It will just initialize it. Or should we give some data? We will initialize it with 0 if that makes sense. So we can give in dimension. We can give the shapes as well. So constant size t pointer of shape and sprites will be calculated as such. So let me implement this. So we will include tensor.h file and the function was tensor create tensor, right? Now the first thing that we need to do is calculate the dimension and should we uh change this to ndem? That would make sense, right? Number of dimensions, and I guess number of dimensions is not required because we can calculate it from the shape, or is it required? Hmm. Let's keep it for now. Okay, so we have number of dimensions, we have shape, size. We can have something like size as well. Size. Size can be calculated on the basis of shape and endem, right? So let's do one thing. Let's create tensor t will be malloc. Um, let's do size of uh, tensor. What happened? Okay, so do I need to typecast it to void? In included file, cstdf is file not found. What exactly is this? So let me delete this for now. It should be fixed. Okay, what is the issue? Now it should be fixed. Conflicting types. With an expression of incompatible type tensor. Isn't this how we do allocation, right? Okay, let me do one thing. So we can have t dot data. No, before that, I'm thinking of returning a pointer. Pointer, should I return a pointer of tensor or not? I don't think so. It makes sense. Let's do this. So t dot data, it will be double double of malloc size of double, but how much data is required, that we need to calculate right first. So t dot size, let's say it is 0 for int I equals to 0, I less than ndim, I plus plus we can have, and instead of 0, f0 we can have 1 here, we should have 1 here. Hmm, t dot size, it should be multiplied, right? Or shape dot I. That makes sense. So if shape is 2 comma 3, it will be 2 times 3 6. So total number of elements would be 6. And here we can have size of double times t dot size. Non-void function does not return a value, so let's return t. And here if t dot data return a null pointer, you know what, you know what, it will be much better if I have it as pointer. Should we or should we not have it as pointer? I am thinking of keeping it as pointer. Let's keep it. So tensor t will be a pointer. Let's do malloc size of tensor. We can have dot to be replaced as, what should we replace as? Obviously this. What the hell happened? Did I do something wrong? Okay, I'll look at it later. Uh, okay, what is the issue? Member reference. So it again needs to be this arrow thing. Now what we also need to check if uh, this makes sense, right? Return null. We need to free t. So we have okay, what we need to set now is just so that we have same things everywhere and okay. So t dot data is this is what is. Now let's calculate the strides. T dot strides again will be malloc. Um, it will be equals to the number of dimensions. So ndim. We will have it as size of int, and if it fails, what I'm thinking of, right, is try to compile it with fill C. So I was looking at it. What is the spell? Fill, not this thing. Where is the official website? Fill C compiler. I was looking at this thing, so we can safely compile our projects with fill C, and it is some sort of a memory safe implementation of C, and I don't need to change a lot of my code, but there is some sort of uh, impact on performance. But if you can have it, then I will try to see if I can compile it with fill C, and then we can stop worrying about at least these checks and freeze and all those that programmers that are usually coding in C that they are afraid of. Then that we need to free t dot data, then we need to free t as well, then we need to return null. And how are we going to calculate strides? It's so for the last dimension, t dot ndim, the strides are equals to 1 for int I equals to t dot ndim minus 2, I greater than equals to 0, I minus minus. We have it as strides t dot strides I will be equals to shape. Okay, shape. Where is shape? Have you allocated shape? We have data, ndim size, shape, and strides. We have not allocated shape yet, right? Let's do shape as well. So shape is also this thing. So we can do malloc size of int, and shape will have ndim if t dot shape is null, return null, but we need to free t dot data, free t as well. Now I guess this should work. So we have defined data, ndim, size, shape, strides, and tensor. But what we haven't done is initialize it. So what was it? I guess it was calloc. initializing all bytes to 0, number of elements and element size. So if it is an array, number of elements and the size of int. So we can initialize it with calloc. Number of elements will be equals to t dot size, and the size of it will be double, right? So it should initialize everything with 0. Strides we have calculated, and I am hoping it is correct. Okay, let's create a free function. Void free tensor. If we are freeing a null tensor, then it does not make sense. Free t dot data, free t dot shape, free t dot strides, and t dot data is equals to null, t dot shape is equals to null, t dot strides is equals to null. Okay, let's implement this in the header file as well. So void uh, free tensor, we will have a pointer. Let's go to the main file and include this. src, it is in core maths tensor.h. Uh, Create tensor, number of dimension, let's say 2, int shape, we can pass shape directly, right? If I remember correctly. Uh, Free tensor pass t is already a pointer. What do I need to do is implement a get function. That will make much more sense. Or even before that, let's try to compile this. So gcc minus o main.c uh, src, what is this? Core maths tensor.c. It will be src core maths. Let's We can also do something like O3 optimization, right? What will output? Printf. Okay, it is compiling fine. So there should be some sort of a get function. Let's create it. So it will return a double. Double get It will take a tensor, and where do you want to get it, right? Some sort of array. So constant location or index, will index make sense? An index will be of int. So if a get function, it will return double. It will take a tensor. We will return some sort of index. Double get. Okay. Can we have get or not? Tensor t. It will have. Okay. It was constant tensor t and constant int index. Non-void function does not return a value. Return well. Okay, so how should we calculate it? We already have strides. I is equals to 0, I less than t dot and dim, I plus plus, hmm, int offset. Let's set it to 0, and offset will be equal to strides in this dimension. So t dot strides times I times index dot I. I hope that makes sense. And we will return, what are we supposed to return? We will go to t dot data, and in that we will return the offset element. So printf, check, so percent %d. You know what? My laptop does not have, sorry, my keyboard does not have backlit, and I am sitting in a dark room. I need to buy a backlit keyboard. So what was the function? I forgot. It was get it. We need to pass t, and we need to pass index, uh, int index, let's say 1 comma 1, 1 comma 2. Will it work? Format specifies type int. What? Double. What is the issue? Constant integer, whatever this thing is. This should be working, right? Hello check 0. Format specifies type int, but double. What was the double format for it? We use %d for int. What is for double in C? Yeah, percent %f, same as verb. Okay, so it is able to get this at that index. Fine. One thing is done, it is sorted. But we should have a check here, right? What sort of check? Um, we also need to have some check. We should know what is the size of index. But in C, this is a problem. Okay. But we will assume that whoever is writing the code correctly passes the index here. Okay, we have get correctly done. We can also have a set function. If we want to set up particular index. P dot data of set is equals to value. And here we also need to pass a double. Let's set it. Set T at index. We will set 2 comma 0. Okay, it is not. It is working. Now, what I want to have is addition function. We want to add two tensors together. Basic ops. So adding two tensors, it will return in a new tensor. So tensor add, it will take two tensors constant t, like no, constant tensor and b tensor add what we need to do is do an assert a dot endem is equals to b dot endem and a dot size is equals to b dot size. Shape, what about shape? Can we compare two arrays whose size we do not know about? Okay, let's do a check first like this. If for int I equals to 0, I less than, no, the better way, since we will be using this quite a lot, bool tensor check tensor shape equal, it will take two tensors if uh, a dot endem is equals to or is not equals to b dot endem, return false. If now let's run a for loop. Int I equals to 0, I less than a dot endem. uh if um a dot shape dot I is not equals to b dot shape dot I, we can return false. Incompatible pointer to integer conversion. Why? Is it because I do not have stdbool.h? I guess this is all that is required. The one shape will be left, but this is something I do not want to worry about right now. Tensor at if check tensor shape equal a vt is b. Okay, now let's create a tensor. Create tensor. Number of dimensions will be a dot endem, and the shape will be same as a dot shape. If again it fails, if it fails, we are already clearing it out, right? Now, for int I is equals to 0, I less than t dot size, t dot data I will be equals to a dot data I times plus, sorry for the notification, b dot data I, and we can return t. Okay, let's check this. We have shape, we have index. Do not want this, or do we? Okay. Um, RA, same thing. Tensor C is equals to add hmm, let's do this, and the resulting will be C, right? Free tensor A, free tensor B, free tensor C. Okay, let's check what will happen. 0. Strange, very, very strange. Okay, why would it be strange in that case? This has to be here, right? Again 0? How? So we have shape, we are index, we are doing this. We are setting the index, adding it together. Then ideally it should be 4. Okay, it is correctly getting set. Tensor C is adding of A and B. Okay, debugging time starts. C dot size percent F, and it will be C dot data I. So ideally it should be RA 200 200 something something. What is happening? Let's see. Uh, 200. Okay, you know what? When you want to do small debugging, go here. See, meanwhile this is working. You know, there is a startup that is being funded by YC. I guess what was called Chad something, right? Chad YC. Chad or Clad? Yeah, this thing. What the hell is this? Should I install it right now? Okay, okay. That landing page was strange. Used by most productive engineers at leading institutions. Control Shift Command 4 for a clip it screenshot. used by most productive engineers at. Okay. Oh, did I miss something so trivial? Okay, but did it change it? I was. Now it is coming as 4. Very nice, very, very nice. Very, very nice. I did not want to be bothered by that particular bug, but all is well now. Printf percent f, it will be get c and index. Hey, it is now okay. Now let's implement subtraction. Add, copy this thing, paste it, do a sub, and instead of this, just put a minus. What happened? Sub. Let's make it -4. To 2 minus minus 4 is 6. So that is working. Let's implement dot product. Dot product will be same again. Where did it go? No, it is not like this. So now dot product needs to be a, what the hell am I doing? It will not be a tensor, it will be a double. Tensor T, create tensor, no need for this. Uh some, yeah, it should be. We should ideally be not returning anything. Conflicting what? Double dot constant tensor. Yeah, okay. Can we print f printf? Error shapes do not match for dot returning 0. Use of undeclared what? Now it should be fine. Let's see. Um, where is it? Uh, dot, and here we can do something like, okay, this is a function name, so we need to do some 8. Makes sense. Okay, now what else do we want to implement? We need to have an exponent, something. Should we have exponent? Does it make sense right now? Okay, what we can do is let's implement a matrix. We have two files, okay. RM source core matrix. We have metric.h that needs to be removed. It should be matrix.c, matrix C, matrix H. Fine. So if and if matrix H, we will define it. Let's include the tensor library. We are in the same folder, right? Uh, tensor.h. Okay. Now the first very easy matrix that we can return is double mean isn't this a very big name for an NR? But let's see. We will include matrix. What was the function? Double mean absolute error something something. If check tensor shape equal a b, we are fine. If they're not equal, f printf tensor shape not equal. You know what? You know what? I have a better idea of this thing. Define tensor shape not equal as f printf std error uh, tensor shapes not equal, and here instead of this we can have tensor shape not equal. We can have it here as well, and we can have it here as well. Let's check this out. um int shape 1 3 2 comma 5. It is still working. Oh, sorry. Tensor shapes not equal. Very, 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 very big breakthrough here we have achieved. Shape, um, tensor shape not equal. Print here. We will return 0. What? What is the issue? Hmm. And here, core maths. Here we need to tell it core maths matrix dot c. Use of undeclared identifier std error. Expanded macro. What is the issue? stdf stdio. Stdio is not used. So what I'm thinking that let's keep all of them here. Will it work now? Why I'm getting meanwhile it is coding. Let's implement matrix. So mean absolute error. So int n will be equals to, let's say, a dot endem or a dot endem or a dot endem or a dot size. So two vectors will be there of shape, let's say 1. So let's say if they are in a row, So my thinking is we need to have it like this, and if uh if a dot shape a dot endem is not equals to 2 and b dot endem is not equals to 2 and a dot endem a dot shape, so the first shape should be equals to 1, right? Is not equals to 1 and b dot shape is not equals to 1, then what we need to do is again fprintf std error. um, what should you print? Shape not compatible to calculate metric. It should be the first shape 0 should be 1. What file has changed? Okay, that is a much easier way to implement this. Whatever this thing gave me, this is much easier way to write it. Include, what is it? Yeah, mat.h. See, this is not giving me an error now. Why? Oh, I am an idiot. What did I do? Okay, so check the tensor shape. What I also want to do is, or is it possible? Is it better to do? That's it. So I just wanted to restrict the shape of the first shape to be one, just like we have it in scikit-learn. Yeah, but I guess this one makes much more sense and it is intuitive. Mean absolute error. 1. So it will be 4 minus 2 is minus 2 divided by total number of elements, which will be 6. So a dot size will be 6, right? So 6 by 6 is 1. That is correct. That is correct. Let me make it 1.33. Makes sense. Makes much more sense. Okay. Now what else? Let me implement a power operation as well. So we should not have maths here. Let's have it here. Uh, Power ops. We will have something like this here again. Um, Conflicting types for power. True, true. Makes sense. So what we can have is um, exponent. That will be better. Exponent. Let's keep it exponent. Tensor T power, and here we don't need B. What happened? We have comma delete. We have a tensor and we have an exponent. Conflicting types per power. What is the issue? Is it declared in maths? C math dot h power. Then what is the issue? I'll check later on. Let me implement it. I closed my editor. Can you believe it? tensor power constant tensor t. I am still not able to understand this. For int I less than t dot size, uh, t dot data I will be equals to power t dot data I, and exponent will be equals to non-void function does not return a value. So yeah, it does it should we return a value here? It should not, right? We can do it in place. Non-void function does not return a value, but it is declared here. What happened? Non-void function does not return a value, but it is a void function. Okay, now it is fine. So void power. We have a tensor. We have power. Main dot c. Um, Not this. A, and we will do the power by 3.14. I do not know if this is correct because I am not aware about the power of 2 to the power 3.14 because who cares? All right. Um, then mean square error. Mean square error can be calculated. Mean squared. What is the spelling of squared? Error between A and B. Right. Mean squared error. Matrix dot C, we can have it as mean squared error Okay, but you know what will be better? What was the formula for this? It does not matter in which order do we subtract it, right? Is this should work? 36. Makes sense, makes sense. Okay, what I also want is a exponential function. Now my challenge will be naming it expo. Let's keep it expo. Okay. This is done. What should we do next? Then dot product cost product. So I had this plan of implementing, we have power, square root, absolute, multiplication, division. We can have multiplication and absolute as well for now. Hmm. Now I'm confused. Should I do it in place? If you're doing scalar multiplication, let's do it in place. Void mul tensor double. Conflicting types for mul. How? C mul function. Do we have something like this in? Yeah, we don't. Um, for int I equals to 0, I less than size. We can do a dot data times I will be equals to a dot data I k, and that should work. Okay, multiplication is done. Now, what was it? Absolute. Absolute is also something that we can do in place. Okay, now this one I can understand that ABS will be okay. My another point is for in place operations, we can specify them like this. That makes much more sense. For in place operation, we have an underscore. Link command failed. Much better. Mean, we can calculate the mean or sum. You know what? What we need, we will be needing a functionality so that we can calculate mean or sum along any dimension. And I think I'll be working on it tomorrow. This has been a good session. We have implemented a good amount of code on our own.